drafter, and I don't have to keep on changing the instruments again and again on my drawing sheet. Well, the next important thing that comes up is triangles, or say the set squares. These set square come in two groups basically, which we use at engineering at graduation level. The more advanced can be used at senior levels, but these are the two basic angles, or say the set square that we use in engineering drawing at UG level. This is a 45 degree by 45 degree triangle, and this is 90 degrees, this is again 45 degrees, and this is again 45 degrees. Whereas here this is 90 degrees, this is 30 degrees, and this is 60 degrees. So using these two set square, I can measure 30 degrees because it is there. I can measure 45 degrees, again it is directly available. 60 degrees, again directly available, and 90 degrees, which is also available directly on the scale itself. Well, I can measure the angles using this, as well as I can draw the angles using this. Now, apart from these angles, set square are very important because we can draw other angles also using it. As I said, 45 degrees can be measured, 30 degrees can be measured, and again 90 degrees can be measured or drawn using these set squares on a t-square that we are going to look, the t-square that we'll discuss in the next slide. Here, take a look at this. This is a 45 degrees set square, and this is that 30 and 60 degree set square. Now we have to make an angle of 75 degrees, and without measuring it we can easily make it by using this. This is 45 degrees, and I'll keep the surface as it is, and this is 30 degrees. So this becomes 30 degrees plus this becomes 45 degrees. So 30 plus 45 becomes 75 degrees. So this is a 75 degree angle that I can make it without taking my D, or without taking my drafter, or without taking any other instrument that is required, or drawing multiple arcs to divide an angle. Again, how to draw 15 degrees. This is particular, how much? This is 60 degrees, out of which I keep this angle, this is 45 degrees. So when I minus 60 from 45, that is 15 degrees. Again, another way, this is 45 degrees, I minus 30 degrees from it, again I have an angle of 15 degrees. So these set square have multiple applications for drawing all the angles from, say, standard angles from 0 to 180 degrees. Moving on, the next important thing that comes is t-square. As we saw, the set square was kept on the t-square. As you can see it here, this particular engineer, or whoever the person who is drawing, this is the t-square, and he has kept this set square on it, and he is drawing a particular angle. Now what is this t-square? This t-square is a t-shaped object. That's why it is known as t-square, but it has a speciality. This particular edge that is there on the left hand side has something of a wood that runs on the left hand side of the drawing board. As we discussed, that drawing board has a left hand edge. Now this particular t-square runs on that left hand edge vertically or horizontally as we align the board, and is able to make us draw horizontal lines. So we can know that according to this particular angle, this is a perpendicular and this is a horizontal line according to vertical, and we can move that this square up and down as well as sideways the way we incline the board. Moreover, these set square are of no use without this particular reference, because we need a horizontal reference for the angle to be measured. Otherwise we cannot draw the particular lines. Next, we have the French curves. These are not basically used, but we use them rarely when we have to make arcs or say curves which are not basically circles. All these different French curves basically cover mostly every arc that an engineer encounters. These arcs are basically drawn by freehand in absence of French curves, but this gives us a better smoothing and better finish of the curves which are not particularly circular, because circular arcs can be drawn, or circular shapes and circular curves can be drawn with the help of a protector that the compass that we'll discuss later on. So irregular curves can be carted or drawn with the help of these kind of French curves. If I have a long curve which is S shaped, I can use this particular thing, and then again if I have some complex figure, I can use any of these set square for having a smooth finish to my curves. The protector, well, as it says, it is a protector. it covers 180 degrees. It comes in two dimensions, a 180 degree protector or a 360 degree protector, but we use 180 degrees because this is the most commonly used, and this can cater for the other side, or say from 181 to 360 degrees also. Now it has markings. It ranges from 0 till 180, and again from 0 to 180. So from whichever way, from left to right, or say right to left, or clockwise to anti-clockwise, we can measure any angle if using a reference, and which is a horizontal line, again as in the form of as it was in set square. We use a t-square for doing that. Now again, see this blue region, this is the reference line, and this is a perpendicular that you have drawn. So for confirming that it is actually a perpendicular, so we have to confirm that it has 90 degrees between these two lines. So we can put a protector. So we can see that one line is coinciding with 0 degrees and the other line is coinciding with 90 degrees. So we are sure that the angle is particularly 90 degrees. So now this is a object, this particular object, it has been magnified on microscopic level. Now I can see these lines. These lines are deformations or cracks on any surface. Now I can see on which angular these cracks are. By putting my D at 0, I can see that these lines, the point from where the lines are originating, I can keep this my D or my protector to see at what angles these lines are getting projected outwards. So I can interpret a lot of things, the crack propagation, and a lot of things that a structural engineer can interpret using this kind of an example. The next are normal scales. There are various kinds of scales, but we do not need to get into details of those kind of scales, because in engineering drawing at this level we are particularly using scales or rulers which have beveled edges and have scale of inches as well as centimeters and millimeters. The basic scale that we use is millimeter, so it is very important that this beveled scale should have the millimeter markings. There are two types of scale that we use. One is a foot ruler, that is 1 foot in length, that is 30 centimeters or say 12 inches, and the other one is the short one, which is just 15 centimeters or 6 inches, which is half of a foot ruler. Pencils. Now we have all the instruments. It's just like having a gun. All the instruments are a gun. Now we need, for shooting down an enemy or for drawing using that instruments, we need pencils. Now this pencil is the most important part of any drawing, because if we use the correct pencil for drawing a correct curve or say a correct figure, only then I'll have a standardized drawing. Now the basic pencils that we use in engineering drawing are 6H, H, 2H, H and F. These are different hardnesses that are shown. The more hard hard is the pencil, the lighter it is, because the surface of the graphite loses itself less on a hard surface rather than a soft surface. The softest pencil we have is 8B or say 10B, which is very dark, which we don't use in engineering drawing. So we have H series, that is 6H, 4H, 2H, H and F. So 6H is basically used for light construction lines, which we just use for reference. Then again 4H is for repenciling the light finished lines, which we want the engineer to know that these dimensions are existing. The dimension line, the center line, the individual object lines, all these are drawn in 4H. Now the 2H is used for drawing the visible outlines or the objects. If I'm drawing a circle, or say if I'm drawing a screw or a nut, I need the outlines to be very clear so that the engineer knows that what is the basic dimension, the inner and outer dimension of it. So I'll draw it with 2H. Whereas H and F are both used for lettering and freehand work. Well, the next slide, this slide tells you what in detail that these are the hardness, this is medium and this is soft. These are different graphites that are used in a pencil. These are basically wood covered graphite. These are hard, ranges from higher level of H to lower level, whereas medium is H, HB, etc. And then we have the soft, which we don't basically use. Now this table shows us that what kind of lines we use. We have construction lines that we use H and 3H, the lead, the guidelines which we use again H, 3H and 2H. Lettering is H, F or say HB, the basic pencil that we buy, Apsara Gold or any other pencil that we buy, is basically HB. It is a medium pencil that we can use for day-to-day work. Dimension lines are again 2H and H. Leader lines 2H and H. Hidden lines 2H and H. Cross-hatching lines again 2H and H. Center lines again the same. Fathom lines also the same. For fathom lines, it is the fathom lines show that the object which it can be after a certain point of time. Say if my hand is here right now and I show this as the final position of my hand, then this I'll draw it with 2H, whereas this I'll draw it with H. This shows that this is the final position of the object, which is this is the final position of the object, but it is not there right now. It is here right now. So I'll draw this as a fathom object and this as my original object. Long break lines, visible lines, cutting planes, extension lines, freehand break lines, all are different applications with different leads. Well, the next, as we know, the technology advances everything. It has advanced pencils also. We are having wood covered pencils which cover the graphite between it, but now we use mechanical pencils which are very easy to interpret. It's just like a pen. We can just press the lead and we can get the lead out from the other side. Well, these pencils have an advantage over the wooden pencils, because the nib, or say the lead, doesn't have to be sharpened from each and every now and then, because if we are sharpening a pencil, we might not get a uniform lead. That is the most important thing for an engineer. If I'm drawing a light line and if I have a blunt pencil, then that light line would be thicker than the sharpened pencil if I'm using for drawing the same line. So I should have a uniform thickness of the lead, the pointed lead, so that I can have the line, uniform lines for each and everything. Here we have 0.2 mm till 0.5 mm leads with different hardnesses that are available, so we don't need to sharpen it. We just need to click it from top and the lead keeps on coming with the same sharpness that it is uniform for the whole point that lead exists. And moreover, the same pencil can be used again and again, so it is kind of energy conservation thing also. So it is more preferable to use mechanical pencils. Moreover, this is more accurate because the uniform thickness is there, uniform sharpness is there, so it is more accurate and it is more neat, because this particular thing does not need sharpening, so we don't keep on spitting the sharpens each and every way. Compass, another very important subject. This is most frequently used object or instrument in engineering drawing. Well, for drawing circles, for drawing arcs which have a particular radius, only particular radius. I'm mentioning it again because if we don't have a particular radius, we cannot use this particular compass. So for drawing arcs or circles or circular objects or cylinders with particular radius, we use this particular compass. This can also be used for marking different points or intersection. Say if I have a line and I don't know the particular length of it, so I draw a ray and I need to have 15 mm, so I'll take 15 mm dimension on the compass and then I'll cut an arc on that particular line, so that shows that I have 15 mm, rather than putting a scale which might give me error. Moreover, if we want to divide angles, we can easily divide angles using this particular compass. Divider, this is another instrument which we kind of take it for reference. See, this is an arc. Both points are pointed, so if you want to see that till where this circle goes, so we can see that this is the center point, and then we can say that this is particular radius, so it will go up till there, and then we can advance it, say on the other side, to say that this circle will go from here. Moreover, for measuring the distance between the curves or whether they are parallel or not, so we can use this particular divider. Say these two pointed curves have, say, distance x. Again, if I keep one point here and one point here, if they both have the distance x, I can determine whether the lines are parallel or not, because the instrument can be set at a particular reading, and then that reading can be used again and again for marking, for measurement, for whatever we want. Sheet holder, well, we need to keep the sheet safe from water, from being damaged, so we just wrap it up, put paper in between and just put it in the sheet holder and keep it so it's safe and sound and it cannot be harmed by any manner. So the next thing that comes, these were the instruments. Now, using these instruments, what all things do we draw? This is another important thing that we have. Lines. any object is formed of lines, different types of lines. Now I want you all to concentrate on this particular table. Continuous thick lines. We will first discuss what type of lines are there, and then later on, after 2 slides, we'll discuss that what particular is the use of that particular line. Now the first shows the letter, the designation letter of that line. The second column shows the type of line, whereas the third column shows the example of that line, that how that line is. And the third section, which is divided in 3 parts, shows that what should be the minimum thickness of that particular line on different sets of papers. So A, the designation is A, which designates continuous thick lines. This is the example of a thick line, whereas this shows that on a sheet of A0 it should be minimum of 0.7 mm thick. So this tells me that if I want to draw a continuous thick line, I should use a pencil which has minimum thickness of 0.7 degrees. I can use a mechanical pencil which has the thickness of lead thickness of 0.7, whereas on A1 I should have the thickness of 0.5, whereas on A2, A3 or A4 it should be 0.35. The same goes on for each and every line that we are going to discuss. Designated letter B, the continuous thin lines. This is a thin line. Then we have a freehand line which is designated as C. This is a thin line. Then we have continuously ruled with zigzag. This is just like an heartbeat. This comes at particular intervals. This is particular interval, say of x distance between two of the intervals. So the third this zigzag that will also come after, say, x distance from this particular zigzag line. Dashed thin lines. These are the thin lines which have equal amounts of drawn and equal amount of free spaces between each other. The F is designated as thick line. The same line, the dashed thin line, is again thicker and more darker, so it becomes more darker, so it becomes thick line. Now we have chain thin lines. These thin lines have a larger line, then space, then this smaller line, then again space. This space, the small line and the space are of equal distances, whereas this is considerably larger than this space and this thin line. This thin line, the short line that is in between. Similarly, we have this thick line, the same of that. Now the chain thick line, the chain thin double dash line, this will again show a particular significance in this line. More lines. Now we have seen the lines. So the visible lines that are there on the drawing, the convention is this line as we saw before. These are heavy unbroken lines used to indicate visible edges of the object.